I just had one go back. It's okay.
Go
I did want to say real quick, one quick go back before we go to questions. So Orion is, by itself, doesn't have much meaning, right? It's part of an architecture. It's part of a system. And we wouldn't be here today without the management and integration of that total system. So I want to thank Jeff Hanley for his leadership of the program and Doug for his leadership at the exploration level, because we wouldn't be here without their guidance and help to get to this particular test. So I want to make sure we talk about that.
With that, we'll start with our questions here. If the media have questions, you can come up to the mic. And if you can, state first your name and affiliation, and then direct your question to somebody if you can.
Yeah, Leonard David with Space.com and AIAA, Aerospace America magazine. Just curious, with all the congressional and political cloud around Constellation, the program, to what degree do you think you can dial back or scale up what you've learned here today? How will it be applied to other systems?
Yeah, I think it's a great question. So there are key parts of launch abort. One, you need to get out of the way quick. Two, you need to make sure that you can steer it so you safely get out of the way. And three, you need to make sure that you have a chance to get the parachutes out. So no matter what the size is, you've got to integrate that system. So I think the key part about this, regardless of the thrust level, is we've shown you can put those disparate pieces together in an integrated system with the computers and everything else and make them work. So I think it's obviously very much applicable to any other system. To the importance of the test. So relative to the launch abort technology, obviously was very important for that. It got us to the next step of saying we can put these complex systems together under high loads, high acoustics, and they perform. So it reduces the test we need to do forward relative to that. But I think it's bigger than that. There's a lot going on in Orion and in Constellation that you don't see because there's no fire and smoke. Right? We're welding a crew module at Michoud in Louisiana. Right? We're flying an rendezvous and docking sensor on the shuttle later this year. We're firing a first stage later this year. We're going to do. We finished our preliminary design for software. All those are key things that people are killing themselves, working hard every day because they believe America should be a leader in space. So a test like this, which goes great and is visible, I think really is a great encouragement for the team and talking about a very visible success for the team. So it helps in that, as far as morale in that sense too.
Okay. So we have another question here. Mute the phone.
Steve, I may add to that. One of my favorite quotes is from Otto Lilienthal, who's a German pilot that actually died flying one of his own planes. And he said to design something is nothing, to build it is not much, to fly it is everything. And so, like I said, the proof is in the pudding. And this is where it all comes together. And that's what makes this such a monumental success, because this system survived in the flight environment and everything worked as we predicted that it would. So that's a testament to our ability to use our analytical tools to predict what we expect to happen. The testing that we do all comes together and gives us high confidence that it's all going to work as a system.